All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's time for DM Radio. Yours truly, Eric Kavanagh, is here. And folks, I am so excited to tackle one of the biggest, hottest topics in the world of data today. Of course, we're going to talk about artificial intelligence. We're going to talk about data centers. We're going to talk about workload orchestration. And yes, that really matters because there are many kinds of AI. We keep hearing all this talk about executives saying, yes, we want the AI, we must use the AI. Well, which one and for what purpose? We're going to talk about understanding your workloads. What is the thing you're trying to achieve? It makes a really, really big difference. And then, of course, you have to understand, do you already have infrastructure? Are you looking to rent infrastructure? There are lots of gotchas, and that's why we have this whole concept of the $10 million questions, because if you ask these questions of yourself and of your team and go deep and really give thoughtful answers, you're going to save yourself millions and millions of dollars. So, folks, we have an all-star cast today. Our good buddy Mark Madsen is here from Third Nature. He did HPC workloads 40 years ago, and he was joking that some things haven't changed too much. We've got Denise Muyco of RAVEL, very interesting company doing AI workload orchestration, and Rich Lappenbush is coming from the manufacturing side. This guy has got a pedigree like you would not believe. He has done some of the most amazing things, and he's got lots of really interesting opinions on what's happening. But let's start off. I'll throw it to Mark to get us rolling. Mark, there's so much excitement about AI. There is so much investment. I was doing my own research today. We're talking hundreds of billions of dollars, and yet guys on LinkedIn like Stephen Wright are saying, "Hey, people, 60+% of AI infrastructure right now is idle, and yet we're pushing forward to build hundreds of new data centers all across America." Well, guess what? There's pushback from communities because electrical prices are going up. Power consumption is a real serious issue. All kinds of things are happening. But Mark, I'll throw it over to you. It's really important to know what you want to do with your AI before you start buying big boxes. Or if you've already started buying the big boxes, at least think more about what is the use case, what data do you have, and how can you align these things to do it efficiently, right?
Yeah, it's definitely the case that a lot of people get out over their skis because they're pushed to do something. I mean, I was an IT manager, I was a CIO, and I know what the pressure is like to just do something because people are asking. And so it's not just fear of missing out, but it's also pressure from behind shoving you. And that leads to demonstrating that you've done something by spending money, right? That's the thing in a lot of big companies is that's the gauge of success. But the reality is that you do need resources to start, but the question is, are you getting the right things? Now, initially it's developer workstations and oh, let's get some high-end workstations or some Mac M4s or something so the developers have a thing to work on. But if you're serious, then you start thinking about pilots and internal work and rolling things out into production, which requires availability and, real IT, not just some developer boxes. And then things get interesting because that's also where the serious money gets spent. And I think that's where misallocations happen. But the structure of the market right now it's complicated, right? It's not just go to one company and buy stuff. And I think that makes it doubly confusing. And I think that's where having, the panel that you've put together here is really helpful because it's that macro level context of what are you doing and what is the supply side of the market doing? Because right now, you mentioned hundreds of billions. It's a supply side market.
Yeah, that's a lot of money. Let's bring in Rich Lappenbush from Supermicro to comment on this. I mean, you're in the business of delivering the backbone of AI infrastructure. What are you seeing in the market? Are you seeing alignment on workloads and orchestration that's efficient? Are you seeing just the whole gamut, or what do you see?
Well, we see a broad array of different people entering with different levels of maturity at the same time. So we have people who are just starting out with dev workstations, onesie, twosie, threesie, and that's their SWAT team, their pilot team to get started. And then we have kind of second stage people saying we're going to need a whole lot of horsepower to grind on whatever we're trying to get done. Sometimes that's imagery. cancer research. Sometimes that's satellite imagery. Sometimes that's as simple as going through the auto parts catalog and all different variations of data from the absolute lowest level to the absolute highest level. So a
Right.
lot of variation, a lot of deviation as well. One of the interesting things during the intro was I wish there were only one problem per customer. But as it turns out, as soon as the first one's off the diving board, the other two, three, and four surface with their problems, which are typically different, have different data, different challenges. So there's usually a set of problems, only one or two that have been surfaced, but often is the case another half dozen waiting in the wings.
Right. Well, that's the thing, right? Once someone on the client side sees the success and realizes, hey, this is happening, they jump into the fray, and that complicates things. And then maybe their use case requires a whole different kind of infrastructure than the use case that you started with, right?
Yeah, it can, or it might require a different orchestrator, or it might require a different memory configuration, or a slightly different switch and networking configuration. It all depends. It's very job based. It's
Right.
not as IT traditionally would set up and run for N months at a time, maybe a reboot once in a while. This is a very different animal. This really is more like factory operations, which is projects per shift per day type
Hmm.
operation.
Well, and it's heavy, heavy workloads. We're talking about massive amounts of data. I'll bring Denise Muyco in. And Denise, I know you and I have a similar past in that you started your business in the visual effects industry. And way back in a former life, a long time ago, I worked with folks that did special effects. I'm talking like the 1990s, right? A long time ago, when these folks would work really, really, really hard to get everything set up. And then you'd push the enter button and go home for the weekend and hope and pray that the job finished by the time you got back. I mean, that's how far back I go. But you were in that business, and so you know what it's like to deal with very large, very serious jobs that are very expensive and have to be right. And boy, when something does not go right, it's painful, right? What do you think, Denise?
Yeah, no, that's our background. We have a great history in running these different types of workloads. And to your point, yes, these very large workloads, and how that kind of translates over into AI. Obviously, it's very similar. As we talked about HPC, and Mark mentioned about HPC. I think kind of looping it together with what Rich is talking about. He says the word jobs, and those jobs are equivalent to us in our language. It's workloads, and those workloads, and Rich identified what some of those different types of workloads are. And I think the biggest challenge is that, you've got a lot of businesses that are just spending, money on on the infrastructure, on the chips, and they may or may not be right sized, right? So people will kind of make decisions, and then the workloads themselves may be insufficient. The infrastructure is not sufficient to the workloads, and so I think that's one of the big challenges is making sure that we're matching up the infrastructure type to the workload type. And so that is where there's a lot of efficiencies that can be had. Generally speaking, I've seen, people buy a fleet of infrastructure that is, very expensive. And if you don't have, not to get so technical, but if you don't have that VRAM right, if you don't have that storage right, and you don't have the speed right that's feeding the chip, then you're really inefficient. And that's something that is a struggle and is a challenge, up front, where, people that are interested in either purchasing or buying or developing an AI factory, that is really something to look at, which is, let's make sure that workload type is meeting the needs of the infrastructure needs.
Hmm. And Mark, I'll throw it back over to you. I remember noticing, and this is over a decade ago, that the HPC world, for some reason, does not, or at least back then, did not even interact with the big data world, which really kind of blew my mind because I went to an HPC conference and I was looking for a Cloudera and Hortonworks and MapR and all these traditional players in the big data world, and none of them were there. But I think now finally we're starting to see this convergence of traditional enterprise IT with HPC because data science is so important. Because AI, let's face it, now it's all called AI, right? Whether it's data science or Gen AI, it's all kind of grouped together in AI. But that's finally starting to happen. But most IT shops are just not really very experienced with these kind of workloads, right, Mark?
Yeah, it's the rare company that had a supercomputer cluster, let alone understood how to apply the techniques. Um, and it has been a long, slow collision, but you're right. I can remember 15 years ago talking with companies and they had lots of data, but it was data parallel work, statistics work, different kinds of machine learning work. Whereas a lot of the supercomputer work, the high performance computing work, was things like simulations and whether it was a weather model or a nuclear blast or protein folding, right? The techniques in use were more high compute, low data, as opposed to high data, low compute. And now we're in this world where a lot of the problems or a lot of the solutions being applied to problems are both or a different mix. And when you bring those things in, you need this new infrastructure. But I like what Rich said earlier, it's job based. That's not what IT was optimized for, right? Optimal IT was let's pack these boxes as tightly as possible because a transaction is a transaction. If you're doing it, if I'm doing it, an order is an order. It takes this much compute, it takes this much memory, it does this much I/O with a tiny bit of variability. And so it's easy because you can optimize that. You can apply queuing theory if you're really sophisticated to run things at huge scales. And this kind of work, analytics work, whether it was business intelligence or data science or AI, is highly variable because it depends on the question you ask, or it depends on the interaction, or it depends on the data that you've got. And it can lead you into suddenly having a big wad of work where before you didn't. And different projects will have different profiles. And that leads to what Denise said, the project defines a profile of work which has a pretty high degree of variability, and one thing leads to another. It's not one, two, three, four, five. It's five projects. One's in pilot, two are in production, and two are still experimenting. Do I let each team get their own infrastructure, go to their own cloud, buy their own servers? Maybe when you're early on, but that's capital intensive and wasting resources. But how do you pack all that stuff into a box? How do you figure that out? That's hard because you're trying to cram a whole bunch of things. This is a much harder optimization problem than workload optimization for an Oracle transaction database.
Right, right. Well, maybe Rich, I'll throw this one over to you, and then Denise, if you want to comment on it. I've been joking lately about my age, saying I'm old enough to remember X, Y, and Z. And I remember way back in the day, it was all about scale up, right? Bigger boxes, more memory, and then it was scale out. And there was the whole Hadoop craze where you're like, oh, just use commodity hardware and we can do your Hadoop cluster. And we actually in our tech lab stood up a Hadoop cluster from the command line with my data scientist pal Jeff Malofsky, and we learned the hard way that yeah, commodity hardware, maybe. Turns out the good hardware worked a lot better. Go figure. So these stories kind of get out there, but Rich, I'll throw it over to you. It's both scale up and scale out, but in a very strategic way that you have to do these things now based upon your workload, your business need, and what you've got, right, Rich?
Yeah, it is. It is. And there's a maturity curve as well. So people will start out and for decades, past decade or two, IT has been focused on cost containment and cost control and reducing waste. Well,
Right.
all of a sudden, they're handed this thing called AI, and they're asked, no, we don't care so much about cost containment. We want actual performance. We want to get product out of this within and weeks and months. And that's a very different animal, very different set of metrics, KPIs than IT's used to. Puts them in an uncomfortable spot. And so they do need a lot of help to help understand these classifications of workloads and the hardware mappings. Sometimes those are great to just prototype on a cloud. Sometimes not so much. No, that's not going to work out well. Or the prototype and the results you might get from a cloud are very different than what you might get on-prem with a dedicated set of 1, 2, 4, 8 GPUs in a lab. And so as a result, it does take a lot of expertise that you need to lean on to understand what's going to work for you, whether you're working in video, whether you're working in live telemetry like a cell phone or mobile provider, or whether you're working with legacy databases like film libraries and things like that. And we have customers who have been working with all over the map. And so it is a big mapping exercise that it's very helpful to work with people who've done this before to help you get oriented the right direction with the right types of memory and the right types of processors. And it's usually a blend of processors. It's not just the GPU, it's not just the CPU, it's usually the blend of the two based on security and performance and other things you're looking for.
Right. Well, we've got about a minute and a half left in this segment. Denise, I'll throw it over to you. There are all kinds of gotchas out there too. I mean, I've been doing a lot of research since we started working with you folks, and KV cache, for example, key value stores cache. If you get that wrong, you're going to have a lot of trouble, right? Real quick, 1 minute.
Well, what I'd like to do is just talk about the constituents and who are the users. So if we separate that out into, data center operators versus the end customer, and end customer could be a knowledge worker or somebody, that is in an enterprise doing their work. So I think I'd like to kind of expand on that. If you want to go to break, that's, please do. But I think
Yeah, yeah, yeah.
that's
Yeah,
a good place to cut.
we'll do that, and we'll come right back. And folks, check out the other half of this on YouTube. It's going to be separate from this show, but we'll link it if you want to watch the presentation that Mark just did. But fascinating conversation already. We're trying to get to the bottom of this. It's going to take a couple more segments. Don't touch that dial. I'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking to Mark Madsen of Third Nature, Denise Muyco of RAVEL, and Rich Lappenbush of Supermicro. We're talking about AI workloads and all this AI infrastructure investment that people are being strongly encouraged to look into. And Denise, at the end of the last segment, you made a really good point about constituents. Who are we talking to? Is this the
Yeah.
buyers? Is this the operators? So take it away.
Yeah. I mean, there are several constituents, but the big two who I'm most familiar with are, data centers themselves and people that are interested in operating and running either what we're going to call GPU as a service. That's a very big kind of hot topic in the way people are defining data centers, being able to either enable neo clouds or the data centers themselves. And the other are the actual enterprises that need those workloads to get done, which are various enterprises. What I think in the way that both, if you're an OEM or a chip manufacturer, we can talk about different markets, but really it comes down to those workloads. So you can have, as been discussed before, what does somebody that's doing autonomous vehicles, like what do they care about? If you take that use case and you understand what is the nature of the GPUs and the network required, and what are the latency issues, we know that to receive that information, to process that information, you're receiving a tremendous amount of video images. You have to process those images. It has to make decisions, and you have to turn it around very quickly. No latency, no mistakes. Right? You're dealing with actual people's lives and security. So that kind of workload is extremely important, not only for the enterprise, but also for what the data center or what that infrastructure must do. So that is, both the enterprise themselves, if they're not owning and operating their own data centers, must have that kind of very tight partnership with that neo cloud or with that data center. So those types of things are extremely important. And then you're looking at, well, let's just talk about things like what data centers care about, which are things like the concept of PUE, which is that is really about how power is being utilized and the effectiveness and efficiencies of that power. How is that best being utilized? I want to kind of just bring in, Rich into the conversation and Mark into the conversation about that. But that really is kind of where rubber's meeting the road because it is about the workloads. It is about how the effectiveness and efficiencies of those workloads are using those chips. And then ultimately, what is being powered? How do you power those chips? What is the most effective use of those chips? That is kind of now we're getting into areas of like national security when you're dealing with things like power. So I'm gonna, I'll toss that over to Rich because I know, Rich, we're working on some of those issues right now with some joint projects that we're on.
Yeah, absolutely. Yeah, there's a number of issues. Typically, once you get the workload honed and defined, you realize the scale of what you might need to run these jobs is much larger than, say, a desktop or even a rack of servers. It's literally dozens of racks of servers. And it's a non-intuitive new type of network system. It's not just a new network protocol. It's a whole new type of switch that's optimized for a completely different type of processing than, say, traditional Ethernet and email and streaming that we're on right now. So it becomes a challenge because all that requires a capital step function upgrade. And with that upgrade provides the initial enablement of starting these jobs. And then that's kind of phase one of the rocket ship. And then after phase one, you realize, oh, we're kind of suboptimal in power and we're kind of suboptimal in GPUs and we're kind of suboptimal in network. Now we know what we need. We need to go do yet another capital upgrade to fine tune kind of our first phase investment. And then at that point, people really start to rock and roll and get what they want. And by then they're starting to see some of the value. And once they see that value, then they're really on board and they're go, okay, now I see how this is working for me. But it does take a significant investment by people who are focused. This is not just buying a box and shoving it in a rack. That is not going to work for this particular challenge in front of us.
Hmm. Yeah, Mark, what are your thoughts on that?
Yeah, it's the myth right now is just like the myth of data science. It's just like all the myths in IT, which is, you know, Horatio Alger stories of the lone developer goes out and does something and builds an AI application and it's a miracle. And there's a lot behind these things, but it it's amazing what you can do with that thing on your desk if you ram a GPU in it. And yet, when you're doing things at enterprise scale, at government scale, whatever it might be, it's a different ball game. But we've dropped the potential for doing things a lot lower. We've lowered that bar, but still, most of the things, if you want to do them at scale, it takes work. So, we go from that IT resources to, well, it's really data center and data center resources, which are really dependent on power. You get that stacking and the capital intensity just keeps rising and rising. And the fact that we measure data center build in megawatts rather than, what we used to, which was floor space, is telling.
Hmm. Yeah, that's pretty serious. And we have an interesting question from one of our live studio audience members. Maybe I'll throw this over to Denise. An attendee is saying, great discussion. As a direct seller, we are challenged by this as well. How do we help our customers clearly articulate the workload requirement? Can you tackle that,
Yes.
Denise?
Yes. That's a great question. That is always where we start. It really comes down to basically three things. The first kind of grouping is like talking about the actual data itself that you want to process. So it's what I mean by that is like what are the file sizes? What are the file types themselves? What's the constitution of that, of the files or the data that you want to process? Then you get into what is the engines that are being used to process the engines and the models, right? Then the third is like, well, where do you want that data, the resultant data to go, right? Those are the ways in which you always want to kind of start from the beginning. That's where to start. And when you get into the that does basically two things. It helps you define what is the infrastructure that you think is going to be best suited, because most of these data centers and neoclouds, they might have a mix of infrastructure, which is definitely the right thing to do. Because if you're doing training versus inferencing, or if you're doing inferencing of large things and you're doing a consistent kind of training, that is what's happening right now. That's everything starts with that workload definition, which is basically the data constitution, the models or the engines that are using to process, and then where do you want the resultant data to go? Those are the big three. That's how to start.
Yeah, and Rich, I'm getting an idea here as Denise is talking about this stuff. The neo clouds, it seems to me that with AI, with the efficient use of AI, the people who get it right, you're going to see them rise head and shoulders above the competition. And I think that's the era that we're in. It's just the beginning right now. But a neo cloud, if you really identify a particular niche, and this is why you're seeing things like GPU as a service, if you really understand where that niche is, where rubber is going to meet road in the near future, and you do this right, you're going to crush it. What do you think, Reg?
Yeah, yeah, it is a challenge though, because you might have the data, but getting the data to the right set of GPUs that have been organized the right way with the right switching and the right security containment so you can process that data in a job is rare. And
Mm-hmm.
that's why all politics is local, and guess what? All data is coming back local as well. And so we
Interesting.
are seeing neoclouds in the metro region who are serving double duty. They're both hosting existing customers and they're bringing everybody up the learning curve at the same time. So, yes, we do see a lot of interest amongst neoclouds who can locally provide that context and get people and their data prepared literally on the right set of hard disks and the right sort of storage formats so they can quickly come in, run some jobs, get some value, and then start their cycle. Yes.
Yeah, and Denise, I'll throw it back over to you. I think one of the real big challenges here, because this is new for a lot of folks, especially IT shops, is that a lot of people don't know what they don't know. And if you don't know what you don't know if this is reasonable or not. And that's why you need experts to be talking to you and to say, no, actually, it should not take that long to do this training exercise. It should not take that long or require that much resource to do this inference. But if you don't know those things, you're kind of in the dark and at the whim of whatever is being done in your organization. What do you think?
Yeah, I mean there's sometimes you won't really know, because if you're using a new model or if you're using different data, just that kind of combination of things, you're dealing with, six factorial of possibilities that can come out, right? But what generally happens, and I think where people need to understand cost versus, efficiency and that balance is really understanding the TCO, the total cost of operation, the total cost of ownership is really important. And for those data center neocloud folks, they care about, the land, the power, the container or the modular data center that it's in, the rack and the compute, the orchestration layer that sits on top of all of that, and then being able to kind of put that in a model where it's consumable for an end user, right? Because I know we have both constituents on this call. And so I think what's important is making sure that value chain that we just kind of described, a lot of our national labs, are working on this, right? So things that are like, chip to grid, what does that TCO look like? How is it optimized? And so the best thing we can do to kind of help right size or demystify, well, how long should something take, right? Is really coming down to that, understanding how to optimize that chip utilization, and making sure everything's like right sized. And there's a lot of, I would say, um, opportunities in various what they're now calling these marketplaces. There's lots of models being it shows up in the marketplace of a neo cloud or of a hyperscaler. They basically will say, well, run a trial. Here's a GPU. It could be a command line, or it could be something a little bit more sophisticated where someone is you can run a workload, and test it yourself. So those are opportunities by which end users or even data center users or neocloud users can trial these things out, so they can right size their infrastructure.
Yeah. And Mark, maybe I'll throw it back over to you. The, it's not necessarily a new job role, but it'll certainly be an expanding job role of the person who understands these things. And, Denise and I think even Rich kind of hinted at this. It's not just going to be one model or two or three models. You're going to have a dozen models in some
Yeah.
large organizations with very different purposes and thus different profiles, different resource requirements. I mean, it's going to be a job just to stay on top of all that stuff, right, Mark?
Mhm.
I mean, that's been my career. I like the parts where we get to talk about data, but it's one of those things where there have been multiple cycles. We used to call it data mining in the late 90s. Then we call it data science. Now we call it AI. Every 10, 15 years, it seems there's a cycle. And you can tell when you're starting to get into a retread where you're doing things that are only useful for maybe 20% of the work, the goal that you have. And so you can tell that you've hit this because the same use cases keep cropping up.
Hmm.
When I was doing what we call data mining, so I was getting a PhD in AI, right? Autonomous vehicle stuff was my thing way back when. And then I got out of that because there was no future in it, right? And so, oh, but you can use this stuff to do data mining. And what was data mining back then? It was the statistics for retail, logistics planning, and things like that, but also the high money ones because that stuff, like disk drives, 4.5 gigabyte disk drives were horrendously expensive. Now we're
Hmm.
talking 40 terabyte drives. And so big pockets, lots of money, blow all that money on things and try stuff out. And it's like, oh, fraud detection, customer segmentation, or customer scoring, next best offer, which is just a different way of doing a recommendation. Those were the things.
Right.
And
Right.
and then you hit the big data era and it's fraud detection, it's predictive maintenance, and it's customer scoring. And here we are with AI, and what are people saying? It's, hey, we can do fraud detection. We can like
It comes
we
back
settle
around.
back to
It
the
comes
the
back around.
techniques that are useful. And this time we're just in that exploratory phase of what's deep learning good for,
Right.
right?
All right.
It's kind of where we are.
Let's put a pin in that, folks. We'll be right back. You're listening to DM Radio. All right, folks, back here on a fascinating DM Radio. We're talking to Mark Madsen of Third Nature, Denise Muyco of RAVEL, and Rich Lappenbush of Super Micro. And now the big question. What is an AI factory? I'll throw it over to Denise first. Go ahead.
Yeah, it's that is such a it's a good question, and it means different things to different people, and you can see how like different organizations, different companies market it. But the way I have like three different kind of definitions, and I'll let again Rich and Mark, you guys jump in here. But an AI factory is basically a bunch of equipment and infrastructure, chips, right? Being able to um, process uh, information, process data. So there is data ingestion. There are kind of a curation of various pipelines. There's models in there that can be trained and you can fine tune. There's a little bit of automation in there. And there is a way to optimize those kind of what I would call more inferencing and training. And then there's continuous feedback. So that is what I think the definition of a real AI factory is. So it's basically taking that data, processing it, and being able to return that. Everything in between. And I'd like Rich, if you want to kind of describe what goes into an AI factory, I think that would be helpful.
Well, unfortunately, it's a rather capital intensive thing right now. Even on a desktop, it can be a very pricey workstation to start an AI factory operation with two, four, or eight GPUs. But ultimately, it's a dedicated set of assets where you're trying to get a process started, and it's not a general purpose computing platform like we've seen in the past, where you might be just using a server for 100 different types and styles. This is where you're taking those specific chips, network chips, central processing chips, graphics chips, ASICs, all sorts of custom types of chips are typically involved, and mixing those together and getting a continuous process where you can mine the data and then remine the data and remine the data and keep getting an iterative process where you can get value back out for the business. And the tough part is, of course, you got to go through that cycle two, three, four times before you really start to see the value. But once the value is realized, then everybody kind of gets it and moves forward and goes, aha, that's why we have this separate thing called a factory and not just a general purpose data center.
Hmm. Well, it's why you're also seeing a lot of the principles of manufacturing come into play here, because in a manufacturing plant, I learned just some history about myself. I learned a long time ago in print production, talking to the printers, I would do newsletters and magazines and things of this nature. And you always go do the press check. I had to go do a press check on Mardi Gras Day one time because you got to do the press check. Don't let them do it if you haven't done the press check. And the guy explained to me, look, man, these are very expensive machines we have in here. And if they're not processing something, we're not making money. So this stuff needs to work, and you really need to figure out all along that workload how things are operating. And kind of to your point, Denise, different parts of the process have different resource requirements, and it takes a while to figure that out. But until you figure that out, you're not running on all cylinders. Once you figure that out, you are running on all cylinders. And that was a weird slip there, cinders. You don't want to burn up your AI factory. But
It was
Denise, what do you
Freudian.
think about that? I'll throw it back to
Yeah. Well, the one thing I also want to bring up too is that once that AI factory is defined, what we're seeing a lot of is the concept of sovereignty, having sovereign AI factories and defining what that really means, right? So generally speaking, it's regionally based. When we talk about sovereign, it's regionally based, it's enterprise controlled. It enables like governments and other enterprises that basically that leads to these AI models being securely and like locally like local processing. You're seeing a lot of things like with edge, like with these edge data centers and edge, these modular data centers being stood up in these various locations, right, all throughout the world. So sovereign AI is also a very, very big topic these days. So I'll kind of pass that off to you guys so we can talk about sovereign AI.
well, I
Yeah,
mean,
I'm
go ahead,
kind of
Mark.
curious about, Rich's perspectives on that. My experience talking with people about that in a few different countries is one, languages, right? All these models are built in either English or Chinese, and there's a concerted effort in many places to do local, whether it's the UAE has two things going on that I know of. Saudi Arabia's got something for the Arabic world. We've got one major one in India, and then we've got a couple state-sponsored ones. And everybody has unique language, which means that these models are viewed as either, the English-speaking world or the US in particular as imposing their views or imposing their will. And the other part of it, I think, is the technology side of it. American tech manufacturers with American models and American software, and there's concern that, it has to be anything but the US and China, right? But what does it even mean to be sovereign is kind of an entirely different discussion. Where do you draw the line in dependency? But I'm curious what, Rich, coming from a global vendor, sees in the sovereign space and how he views that market. Like, what do you think?
Yeah, I think there's a hangover of cloud still by a lot of the people who are saying, I don't want it to go like it did last time. It didn't exactly meet my goals last time. I want it to be more like this. I want it to be more Arabic. I want it to be Urdu or whatever. And I've had the luxury of working with global customers and saying, look, it's nothing English based or US centric. Ultimately, whatever you say or see or do or put on camera is going to get boiled down to tokens. And
Mhm.
those tokens are going to serve you as you start to build your models, and your models will serve you to build value. And yes, you might be running the monitoring system in English, and you might be running the language processing in Arabic, but ultimately it's all going to turn into tokens, and it's
Mm.
all going to be mining for your value. Now, how you structure that and where you want to do that processing absolutely matters. So you may say, "Oh, it's I don't really care about this at all. It can happen anywhere. I can outsource that." But no, no, no. This thing is really important. I don't want to outsource that. That's critically important. We can't let somebody even take any risk of getting into that, whether it's a stock exchange or customs trade, commerce, data, taxation, things like that. These are critical functions of countries and counties and states and provinces, and so it's important to each of them to protect their protect from the risk that's present every day. And one thing not said yet, but is in the background like a shadow, is the level of cybersecurity attacks has just gone through the roof at the same time. And this is a nascent area where haven't figured out how to protect it to the same degree we have, say, a web page or a hard disk yet. So it's super important we get there together, that we figure
Mm.
out the sovereignty, we figure out how to get them mapping to those tokens, and we figure out an appropriate level of security for whatever they want to do.
Data is really hard to move around. I think that's one of those aspects of sovereignty. It's easy at small volumes, but once it gets big, squeezing it through internet pipes gets to be kind of pricey. And to me, that's part of like what you triggered was that this is part of the overall infrastructure challenges. Everybody's focused on compute. You got this big pile of data that has weight and it's hard to shift around. And so once it's in a place, you're sort of locked in. And I know, Denise, you had a background in heavy processing and imagery and video, right? I mean, what are your thoughts on that?
Yeah, I'd say let's pick that up for the podcast bonus segment, which is about 8 minutes long. And I think it's an excellent question because you get all these, you either have lots of small files or lots of really, really big files. And those are very different workloads. I remember the days of the very, very big files, and you would work
Mhm.
all day long for weeks to get it just
Mhm.
right. Again, before you hit that enter button. I mean, I remember like when guys would just get the new computers and think that was going to solve the problem, and it didn't solve the problem. They had to figure something else out. Well, folks, don't touch that dial. Podcast bonus segment is coming up. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on DM Radio, talking to Denise Muyco of RAVEL, Rich Lappenbush of Super Micro, and Mark Madsen of Third Nature. And Denise, data does have gravity. I was just
Yeah.
bragging about how I used to walk around with my SideQuest disc because I'm a gearhead and I thought that was cool. But, I don't think they're around anymore. But talk
Yeah.
about the gravity of data and how that impacts things like processing and even power.
Yeah, it's just a confluence of all these things kind of coming together, right? So you're seeing like a good use case would be I am a manufacturing company. I have a bunch of sites where I have inventory and I'm trying to assemble these things. I'm looking to pick, pack, and ship, and so what the use case here is that I want to find the best routes and the best ways in which I can create my business efficiencies. And so I have to train a model first and understand kind of routes and inventory and how purchasing works. So I basically will ingest all that information and data just on how inventory works. And all of that information and data needs to be centralized so that the training can actually take place and be fed into, an LLM, for example. And so therefore that takes place. And so how does all that data get, properly assembled? And those are going to be, companies. There's lots of companies out there on the market right now that are trying to assemble all of that data so it's centrally located, and then you feed the actual GPU the information. So after that training is done, then you get into query land, and now the actual enterprise themselves can now query to basically ask that LLM, what is the best route? What is the best what's the best procurement time? Like, right? So that's a really good use case of lots of data. In that particular case, it might not be, the data might be small itself, the file size might be small, but it's just going to be a lot of processing. That is definitely one kind of use case. The other we kind of used is like with autonomous vehicles, which is cameras, around a car, all that information needing to be, again, provisioned and proper order of operation. That's when you have to basically get to the edge. You must have edge, very low latency when you're dealing with the size of those files. They're huge, and being able to make determinations and like from a deterministic engine perspective or policy engine perspective, where you optimize, right? And all of that is now going to be impacted by how do you power? How do you power all of that? How do you power those GPUs? If you're, in a big metropolitan area, how is that going to impact, the rest of the community around that's using that? Like, what do you do? And so those are things where you get into really interesting things like, well, can you move the workload? Can you move the workload somewhere else that is not necessarily localized, that can be then moved over? The data can be ingested, and then can some of that data, some of that offtake, can that be moving to another location to be processed and then to be turned back around? So those are really interesting questions because you're dealing with things like, how do you power that compute? And if it's better to move the workload to a place that has more power capacity to power that job, if you will, or that workload. And that again is dependent on how important or what is the priority of that workload to be turned back around. So an autonomous car having that information is critical to be turned back around. Maybe the manufacturing use case can be, rather than competing for that local power and that local processing, but maybe that can now be shifted over to, and federated, what I would call more of a federation of being able to move those workloads to another place where the cost might be lower, the power might be more readily available, that it might be, I'm just making this up in terms of like, we're talking about PUE, where there's more efficiencies in terms of how that chip itself is being cooled, because now you can lower that TCO, and you can also lower the cost of power to cool that chip. If it's going to be something like a direct to chip cooling, or if it's going to be immersion cooling, those things are all important. So again, the size of that data set and the importance of how that data set is prioritized to be returned, those are all very important I would say, order of operation, how a policy or deterministic engine can be decided. Those are all very critical points, and that are here today that can certainly those questions can be solved.
Yeah, like I'm thinking, Mark, I was reminded of ETL versus ELT, right? The cloud came along. I think it was Synopsys, our buddy Yves Desmonchaux, who was
Yeah.
like, well, let's just put it up in the cloud and do the transformation there because it's cheaper and we have more compute power, right? It's kind of similar, but you have to be able to decompose that workflow and move things around. And that's a bit of a challenge, right, Mark?
Yeah, that ability to do the processing where the data is. Um, but then that means that the data is the thing that's weighing you down and you can't shift the processing. And so, we kind of go back to the workload. If you're doing heavy vision processing on video files, that's one thing. If you're doing, chat or RAG conversations where it's a search and you're prompting something and getting some text back, that's much more portable, right? And maybe it's the life cycle. Training isn't portable because there's a giant wad of data and a bunch of processing to be done, and you have fewer options to move that. But maybe the inferencing, which is inflowing data from the client or the user and outflowing data with small access gives you the ability to distribute that process or the data. And so it kind of goes back to that, what's the application? What's the job to get to the workload?
Hmm.
And that's what, to me, you have to characterize in order to figure out what your options are.
Hmm. A lot of questions to be asked, the $10 million questions. We got about 1 minute left. Rich, any final thoughts from you? Any advice out there for folks looking at all this stuff?
I- I'd suggest the following that, once you get your model and your value proposition working and cycling, don't assume it's going to live in the same place. So, you know, coming back to the most basic, the auto parts catalog, once you have that all fine tuned and you figured out how your distribution's working, you might be surprised to learn that the average cell phone can do image pre-processing.
Hmm.
You don't have to upload massive video files necessarily if you have the right software down on the phone, and you can do pre-processing at the edge at the node, and then but still use that model that you've already created in a new and unique way to get more value out of it.
Hmm.
So the value proposition will evolve as you have an asset set in your data. So data doesn't just become raw data you have to reprocess each time. You get to
Right.
build these assets successively up from nothing.
I love it. Well, folks, look these folks up online. Mark Madsen, Third Nature, Denise Muyco, that's Muyco, and Rich Lappenbush on LinkedIn. What a fascinating show. The AI era is here, folks. Make the most of it. We'll talk to you next time. You have been listening to DM Radio.